Hi, welcome back to Science 1206, the motion unit. I'm Miss Ledwell, and in this video, we'll talk about accuracy and precision. Let's begin. What is accuracy? The accuracy of measurement refers to how close a measurement is to the true or accepted value. If you placed a 100-gram weight on a balance, an accurate reading would be exactly 100 grams. Calibration is adjusting an instrument, tool, or measuring device to provide results within an acceptable range. By adjusting the measuring device to match a standard, calibration ensures the accuracy of the readings. If instruments and measuring devices are not properly calibrated, they may not be accurate. Accuracy is really important in science, so how do we improve accuracy? To improve accuracy in experimental results, several measurements should be taken, and the average measurement should be used. Average measurements are more accurate than any single measurement. Let's look at an example. In an experiment to determine the density of the metal cube, the following data was collected. In trial number 1, the students got 11.10 grams per centimeter cubed. In trial 2, they recorded 11.08 grams per centimeter cubed. And in trial 3, they recorded 11.09 grams per centimeter cubed. When looked up on the table of values, the density of the same metal cube is recorded as 7.87 grams per centimeter cubed. How accurate is the collected data? The answer is the collected data is not accurate because it is not close to the true value of 7.87 grams per centimeter cubed. Let's look at another example. The true density of a substance is 8.90 grams per centimeter cubed. In an experiment to determine the density of this substance, the following data was collected. In trial number 1, the results were 8.92 grams per centimeter cubed. In trial number 2, the results were 8.89 grams per centimeter cubed. And in trial number 3, the results were 8.91 grams per centimeter cubed. How accurate is the collected data? The answer is, in this case, the collected data is accurate because it closely approximates the true value of 8.90 grams per centimeter cubed. If you look back up at the data collected in the 3 trials, you'll notice that there's only 0.01 or 0.02 of a difference in the numbers. Now let's look at precision. Precision in measurements means how repeatable or consistent results are when you measure the same thing multiple times. It's like hitting the same spot on a dartboard over and over again. If your darts land close together, you're precise. Precision is often related to the quality of the measuring device. A precise measuring instrument will give nearly the same measurement each time it's used. Think of a ruler. If it only has centimeter marks, you can only guess the length between them, say 5.3 or 5.7 centimeters. But if it has millimeter marks, you can be more exact, like 5.35 centimeters. So a ruler with millimeter marks gives you a more precise measurement because it lets you be more specific. Measurements can be precise, but not accurate. For example, the measurements may be consistent and reproducible, which means they're precise, but they may not be close to the true value. Not accurate. Let's look at an example. We'll revisit the same examples we looked at for accuracy. In an experiment to determine the density of the metal cube, the following data was collected. In trial 1, the results were 11.10 grams per centimeter cubed. In trial number 2, they got 11.08 grams per centimeter cubed. And in trial number 3, they got 11.09 grams per centimeter cubed. When looked up on a table of values, the density of the same metal cube is recorded as 7.87 grams per centimeter cubed. So the question is this data precise? And the answer is that although this data is not accurate because it's not close to the true value, it is precise because the data is close together. That is, there is only a slight variation in the data. Additionally, the measurements are reproducible. In repeated trials, the measured values were very close to one another. Let's look at another example. So what are the differences between accuracy and precision? The following diagrams illustrate the difference between the terms accurate and precise when someone is aiming for the center of the board. The first diagram is both accurate and precise. The person was aiming for the center of the board, and the darts are clustered in the center of the board, so they're accurate. They're also precise because they're close together. Our second diagram shows not accurate but precise. The person was aiming for the center of the board, and they are far from the center of the board, so this data is not accurate. It is, however, precise because the darts are close to one another. Our next diagram shows accurate but not precise. It's accurate because it's close to the target area, which is the center of the board, but not precise because the darts are far apart from each other. So they're not getting consistent results. Our last example shows not accurate and not precise. The person was aiming for the center of the board. The darts are nowhere near the center of the board. So in this case, it's not accurate, but also it's not precise because the darts are not close to one another. It's not repeatable or consistent results. Now it's time to continue to the next video. Take a 30-second break, stand up and stretch, then continue on to the next video.